Uh, Hello students, in this video we are going to see about a inverse Laplace transform. So in this unit, that is Laplace transform, there are two types, Laplace transform as well as inverse Laplace transform. In the previous videos we have seen about Laplace transform. Now we shall see about inverse Laplace transform. Okay, and in Laplace transform we have seen a conversion of a function of t to function of s. And inverse Laplace transform reverse, that is it conversion of function of s to function of t, function of s to function of t. Here the questions of Laplace transform will be the answers of inverse Laplace transform, whereas the answers of Laplace transform will be the questions of inverse Laplace transform. Suppose we have function of t, we can convert it to inverse Laplace transform, that is Laplace transform that is in function of s. Suppose if you have function of s, we can transform reverse to actual function, that is a function of t. So the applications of Laplace and inverse Laplace both are applicable to ODE. So the solving of ODE, ordinary differential equations. How to solve ordinary differential equations? General method we have already done in differential equations topic. But here we solve the ordinary differential equations using Laplace transform as well as inverse Laplace transform. So let us see about inverse Laplace transform definition. So here, if f bar of s is the Laplace transform of a function f of t, then f of t is called the inverse Laplace transform of f bar of s. So here, in Laplace transform, we have seen L of f of t is equals to f bar of s, isn't it? Function of t to function of s we have seen. Here reverse. Taking L to the right hand side, we get L inverse. So that is L inverse of f bar of s is equals to f of t. Okay. So L of f of t, I'm taking L to right hand side, we get L inverse. L inverse of f bar of s is nothing but f of t. Here the definition says that if f bar of s is the Laplace transform of f of t, then f of t is the inverse Laplace transform of f bar of s. That's the definition says. So if f bar of s is the Laplace transform of a function f of t, then f of t is called the inverse Laplace transform of f bar of s. And it is denoted by what? L inverse of f bar of s. That is f of t is equal to L inverse of f bar of s, where L inverse called the inverse Laplace transform operator. Okay, which transforms the variable s to t, function of s to function of t. Okay, let us see the formulae about the inverse Laplace transform. Here the left hand side part we shall see the Laplace transform formulae. The right hand side we shall see inverse Laplace formulae. So same as it is in the derivatives and integrations reverse, the Laplace transform inverse Laplace transform also reverse, that is sin theta derivative is cos theta, whereas cos theta integration is sin theta reverse. So derivative and inverse or reverse, same as Laplace transform and inverse Laplace formula are reverse. So if you see the first formula of Laplace transform, we have already learned in the first part of this unit, that is L of k, L of any constant is equal to k by s. So taking L to right hand side, what do we get? L inverse of k by s is equals to k. We can say that k by s is equal to k, or 1 by s is equals to 1, like this. So we shall learn like this only. L inverse of k by s is equals to k, the reverse of the Laplace transform formula. The second formula we have learned in Laplace transform is, sorry, okay, Laplace transform of e power a t is equals to 1 by s minus a. We have already learned. Here, taking L to the right hand side, what do you get? L inverse of s minus a is what? E power a t. Same as in Laplace transform, we have learned Laplace transform of e power minus a t is equal to 1 by s plus a. What is the inverse Laplace transform of s plus a? Is nothing but e power minus a t, like this. Okay. In the same way, we have learned Laplace transform of sin a t is a by s square plus a square. Since here a is constant, we can take it to left hand side and L to the right hand side. So what do you get if we take a to left hand side? What's left? 1 by s square plus a square is left. L inverse of 1 by s square plus a square is left. As a is gone to the left hand side, we get 1 by a sin a t. So like this, 1 by a sine t. Since it is constant, we can take it the right hand side. So like this. So the formula, fourth formula is L inverse of 1 by s square plus a square is 1 by a sine a t. Same way in Laplace transform, we have seen L of cos a t is equals to s by s square plus a square. So L inverse of s by s square plus a square is cos a. And the sixth formula is in Laplace transform, we have learned L of Laplace transform of sine hat is equal to a by s square plus s square minus a square. Here, same as here, we take it to left hand side. So what is the L inverse of 1 by s square minus a square? So taking a to left hand side, we get 1 by a sine hat. So next, the Laplace transform of cos hat is s by s square plus a square. So taking L to the right hand side, we get L inverse of s by s square plus a square is cos hat. The same way, Laplace transform of t is 1 by s square. We have already learned in Laplace transform topic. Here, the reverse of this one is L inverse of 1 by s square is nothing but t. Okay. And as well as here, Laplace transform of t power n is, we have already learned like this, but we use mostly this n factorial by s power n plus 1. Here, since here also n factorial is constant, we can take it to left hand side. So what do we get? What do we get? T power n by n factorial. What is left in the right hand side? Only 1 by s power n plus 1. So take L to the right hand side. What do we get? L inverse of 1 by s power s n plus 1 is nothing but t power n by n factorial. This n factorial gone to the left hand side since it is constant. In the sine at and cos at formula, like this, we have taken this. So L inverse of 1 by s power s plus 1 n plus 1 is e power n by n factor. These are the formulae. So no need to learn specially, because once if you know the formula of Laplace transform, the inverse Laplace transform formula are very easy. Okay. As we have seen in Laplace transform, the linear property here also works. That is constant, we can take it outside. So that is if f bar of f1 bar of s is and f2 bar of s or Laplace transform of f1 of t and f2 of t respectively, then what is L inverse of c1 f bar of s plus f1 bar of s plus c2 f2 bar of s. Here we can divide these two functions separately. We can find the Laplace transform, inverse Laplace transform. We can take the constant c1, c2 outside like this. So we get c1, c2 outside. C1 into L inverse of F1 bar of S. Here F1 is not there. Actually, F1 must be there. Okay, next plus C2 into L inverse of F2 bar of S. Like this. So where C1, C2 are any constants. So the constants we can take it outside, as we have seen in derivatives, integrations, and Laplace transform also. If there are any constants, we can take it outside. Here also L inverse, that is inverse Laplace transform. If there is any constant, we can take them outside. So we shall see the basic formula. Okay, as we have seen in the previous topics. Okay, here what are the topics required here? So inverse Laplace transform topics are, the first one is basics. Under the basic, using general formula, and as well as here the basic problems based on partial fraction. And second topic is first shifting theorem. The same topics repeats as we have learned in Laplace transform. Same topics, same names. Here, first shifting theorem in inverse Laplace transform. We have seen first shifting theorem in Laplace transform. Here, first shifting theorem in inverse Laplace transform. Here, next, the third topic is second shifting theorem in inverse Laplace transform. And the fourth topic is inverse Laplace transform of derivatives. And fifth topic is inverse Laplace transform of integrations. The sixth topic, inverse Laplace transform of transform multiplied by. Okay, transform multiplied by s power n. And 7, inverse Laplace transform divide by s power n. Divide by s power n. So these are all common topics we have seen. There we have seen inverse Laplace transform of derivatives there. Here, inverse Laplace transform of derivatives. In Laplace transform, we have learned Laplace transform of integrations. Here, inverse Laplace transform of integrations. There we have seen Laplace transform multiplied by t power n. There in Laplace transform. Here, inverse Laplace transform multiplied by s power n. There we have learned Laplace transform divided by t power n. Here we learn inverse Laplace transform divided by s power n. Like this. And the eighth topic extra one is convolution theorem. Okay. Here we learn convolution theorem. Okay. That is extra. And ninth topic is applications. Under the applications, we learn solving of ODE. So I told you that starting of this topic, the application of Laplace and inverse Laplace is a solution of ODE. That is, we solve the ordinary differential equations using Laplace as well as inverse Laplace. We need both Laplace as well as inverse Laplace, not a single inverse Laplace transform. We need Laplace as well as inverse Laplace transform. So they now, out of all these topics, the important topics are here. The first shifting theorem is very important, and the basic problems, under the basic problem, partial fraction is very important, and the convolution theorem and solving of ODE. These four topics out of all inverse Laplace transform, these four topics are very, very important. And mostly the 8th and 9th topics, convolution theorem and solving of ODE. And never seen a question paper without any one of these two topics. So I've never seen any question paper, any one of these. So without convolution theorem and without applications of solving ODE, I've never seen a question paper. Any one of them, 8th or 9th, definitely will come in the exams. Okay. If you learn these two topics, 8th and 9th, 10 marks guarantee. So out of 14 marks, you see the 10 marks is for long answer questions and and two short answers, two and 2 plus 2. So the short answers we may get any from anywhere, but here, so 14 marks. So 10 marks question definitely we can answer. We can answer use if you learn 8th and 9th topic. You may be thinking that I'll directly learn 8th and 9th topic, but without knowing all these topics, we cannot learn these two topics. Okay, we have to learn all these topics. So now let us move to the basic problems. That is, in this video, we shall learn only the basic using the formula. Using the formula, partial fraction separately I'll explain in a different video, and we shall see the basic using basic formula. Let us see this. So the first question is L inverse of 2s minus 5 by s square minus 4. Here separately we do 2s by s square minus 4 minus 5 by s square minus 4. So separately we do. Here we apply the linear property. By the linear property, we can take 2 outside, 2 into L inverse of s by s square minus 4. Okay. And as well as 5 outside, minus 5 outside, L inverse of s square minus 4. Okay. Now, what is the formula for s by s square plus a square? Here a square is nothing but 2 square. A value is 2. S by s square plus a square is cos h80. S by s square plus minus a square is cos h80. So here we get cos h80. What is the value of a here? 2. And next as well as 5 into L inverse of s by 1 by s square minus a square. Here also a square is 2 square. A value is 2. 1 by a, that is a value is 1 by 2 into sin h80. A value is 2. 1 by a sin h80. That's the formula. Direct for using the formula. The first topic we see only the problems related to only using formula. Okay, and direct formulas. Okay, now here see the second question, L inverse of s square minus 3s plus 4 by s cube. So here also we divide s square by s cube minus 3s by s cube like this. So if we divide, what is s square by s cube? Nothing but 1 by s minus 3 by s cube. S cancels, we get minus 3 by s square, and 4 by s cube as it is 4 by s cube. Okay, here also we apply the linear property. Using the linear property, we get L inverse of 1 by s minus 3 outside, L inverse of 1 by s square, and next plus 4 by s cube is 4 outside, L inverse of 1 by s cube. This is by using linear property. We can take constants outside and separately L inverse to these three functions, different functions, different terms. Okay. And next, what is L inverse of 1 by s? The first formula. So here now, so we see here the first formula, L inverse of 1 by s is nothing but 1. So direct formula. This is the first type of problems. Direct formula 1 and minus 3 as it is. And here 1 by s square plus 1 by s square is nothing but t. Here we can see L inverse of 1 by s square is nothing but t. Okay. And next here 1 by s square is 3t. Next 4 into, here 4 into 1 by s power n plus 1. Here n plus 1 is 2 plus 1. Is what? T power n by n factorial. That is t power 2 by 2 factorial. So 2 gets cancelled. We get 1 minus 3t plus 2t squared. Okay. 1 by s power n plus 1. So see this one. T power n by n factorial. Here s cube. Cube is nothing but 2 plus 1. So t power 2 by 2 factorial. Like this we get. So these basic problems. Okay. So we require only the thing formula, direct formula. Okay. And next we shall see about find L inverse of 2s plus 1 by s into s plus 1. So the previous two problems, the denominator is only single term, but here two terms. So if it is like this, we can divide simply. So 2s plus 1 can be written as s plus s plus 1. 2s can be written as s plus s. So that we can separate here s by, okay. So here s by s into s plus 1. So we write like s by s into s plus 1. Next s plus 1 by s into s plus 1. So we write s plus 1 by s into s. So here we can cancel s and s plus 1, s plus 1. So here after cancelling s, we get 1 by s plus 1. So after cancelling s plus 1, s plus 1, we get 1 by s. Now we apply L inverse for these two. So separately. So what do we get? L inverse of 1 by s plus 1, L inverse of 1 by s. So L inverse of 1 by s plus a, s plus a e power at, the formula, using the formula. So what is a? Nothing but minus 1. Okay. So minus, so e power s plus a is minus at. Here in the a is nothing but 1. And L inverse of 1 by s is nothing but 1. This is the first formula. 1 by s minus a is e power at. S plus a is e power minus at. So don't forget the formula here. The second and third formula. L inverse of 1 by s minus a is e power 80. S plus a is e power minus 8. Now we apply this formula. Okay. And next, this is the answer, e power minus a minus t plus 1. So if we apply Laplace transform this to this answer, we get the question like this. Okay. So that's why I told you the first part, the Laplace transform questions are here answers. Here the answers are, here questions are, the Laplace transform answers like this. So we can do the reverse of this. Okay. And next, we shall see the next problem. Now find L inverse of 3s minus 8 by 4 into s square plus 25. So now separately we do 3s by 4s square plus 25 separately here. Now here we have taken 4 common, not actually required. So no, 1 by 4 s square plus 5 by 2 whole square. Here 25 by 4. 25 by 4 is nothing but 5 by 2 square. Here also same thing. 3s is the numerator, minus 8 in the numerator, and 4 after taking 4 common, s square plus 5 by 2 whole square like this. So now here we apply the Laplace transform, inverse Laplace transform on both sides. Here we have taken only f bar of s. Now inverse Laplace transform, if we apply here using the linear property, we can take s a outside. S by s square plus a square is cos 80. Here in this nothing but a is nothing but 5 by 2 minus 8 into 1 by s square plus a square is 1 by a sin 80. Here 1 by a is nothing but 5 by 2. 5 by 2 sin 80. So like this. So 5 by 2 we can take it 2 in the numerator. So 8 is 16 by 5 sin 5 by 2t. The first term is as it is. So this is the final answer. Okay. So let us see the last problem in this topic, that is using the basic formula. Advanced problems, let us see in the next topics. Okay. Now here we see the fifth problem, L inverse of s by 2s square plus a. So here also we take 2 as common here. Whatever here is a square is there, we have to take the common, the constant as common. So after taking 2 common, so we get 2s square plus 8 is s square plus 4. Okay, after taking 2 as common and applying inverse Laplace transform, we get this one. Now here, after taking 2 common, we get s by 1 by 2 common, s by s square plus a square. Here a square is nothing but 2 square. What is s by s square plus a square? Sin cos 80. Here in this case, a is 2 square, that is 2. So cos 2. So this is direct formula, using the direct formula. Okay. As I told you, the basic problems we shall see. The first topic is using direct formula, and next using the partial fraction. Using the partial fractions. That is, The previous problem, if we see this one, so simply 2s we have written s plus 1, so directly we have divided directly. This suppose if it is not possible to do like this, so to do the partial fraction, this is simply we have done. But if it is complicated, we have to apply some partial fraction methods which we have learned in intermediate. So in the next video, we shall learn the inverse Laplace transform using partial fraction. That is, under the basic problems, we shall see the second topic, using the partial fraction. After doing partial fraction, we apply the basic formula. Okay. Next topic, we shall learn about this topic. Okay.